Hi friends, welcome back. We will explore conversational language understanding capability of Azure AI language service. Uh, we expect computers to be able to use AI to understand natural language commands, either either spoken or typed. For example, one might want a home automation system to control devices in their home by using voice commands such as switch on the light or put the fan on like this. AI powered devices can understand these commands and take appropriate actions. And in this exercise, we will use a language studio to create and test a project that sends instructions to devices such as lights or fans. And we will be making use of conversational language understanding service to configure this project. So, conversational language understanding is a capability of Azure language service AI. Okay, and as you can see, I already have logged into my language studio. Before this, I had created Azure AI language service, and then I launched this language studio. If you don't know how to create this service and how to log in to Language Studio and how to reach till here, then please go ahead and watch my previous video in this video series. That is uh, Azure AI Services with the demo. Okay. Now the as usual, the very first step is to create a new project. You have to click on create new, and we are interested in this one today, conversational language understanding. What it does is build natural language into applications, bots, and IoT devices. Click on this. uh, this is the Azure resource which I had created earlier. Here we will have to enter basic information. Okay, give your project a name. I'll just give uh, con lang UND, conversational language understanding. Okay, and please make a note of this name because you need it later in the next steps. Con lang understanding and okay. And utterance primary language, I'll put it English, and I'll put some description. Whatever is fine. Click on next and then create it. And the next step is to add entities, intents, and utterances. An intent is an action you want to perform. For example, you might want to switch on a light or turn off a fan. In this case, you will define two intents. One to switch on a device and another to switch off a device. For each intent, we'll we'll have to specify sample utterances. Okay, that indicate the kind of language used to indicate the intent. I'll explain one by one in the next steps. So we are under schema definition now. Okay, here we will have to add intents. Add intents and entities to your schema. Intents are tasks or actions that user wants to perform. Okay. Uh, Intents. I'm going to add intents now. Add in this page, as you can see here, an intent represents a task or action that the user wants to perform. These are the examples. Book me a flight to Rio next week, like this. Now, our intent is to switch on or switch off a light or a fan. Okay, so our intent name should be switch underscore on. Okay, and add intent. So once you have added the intent, yeah, this is the intent which we just added. Click on this. The next step is to add the labeling. I mean, in the data labeling page, we will add utterances. Okay. Now, as they have already given the explanation here. To add an utterance, first select an intent that user intends to accomplish. Now, choose the intent which I have added in the previous step. Switch on. Okay. Utterance. Utterance could be like this. For example, turn on, turn the light on. Okay, and press enter. Write your example utterance and press enter. Every time you want to add some utterance, you will have to add that utterance and press enter. Now, this intent is associated with this utterance now. Okay, we will have to add at least at least five utterances for one intent. We'll add we'll we'll try to add some more. For example, uh, switch on the fan. Press enter. Uh, Put the fan on, like this. Put the light on. Switch on the light. Turn the fan on. Different user or different human being uh, may may try to say the action in different words. I mean, using different words. One may say turn turn the fan on, or one might say put the fan on, like this. Uh, in 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 every situation, whatever the user says, the model should understand it properly, and it should take action accordingly. That's why we'll have to put multiple types of utterances, like this. Okay. Now, the next step is uh, in this activity pane. We'll have to add the entity. Click on add entity. Our entity in this example is a device, because it's a light or fan. So it's a device. So entity name is device, and choose list here. The list component represents a fixed closed set of related words along with their synonyms. The component performs an exact text match against the list of values you provide. This is just an example. Okay. Now we'll add the entity. Yeah, the entity is added and it is device. Okay. Now the next step is mark which word is uh, entity among these lines. Okay. Uh, just move your cursor, move your mouse to F. Okay. Click that. Move your mouse again till end of the fan. Okay. Then again click that. You will get a box like this. You have to choose a device. Click on device. Now, what you just did is you made this word fan as a device entity. Okay, like that, you will have to do in every utterance. Click on click beside L and then click beside T and then choose device. Okay, like that. Do it for all of them. Okay, so we identified and marked all the all the device entities. Actually, this is wrong. Okay, let me add it once again. Okay, there is option here to remove the label also. Okay, I could remove the label. Okay, now I have made all these as device entities, light and fans. Okay, I'll next step. I you should not forget to save changes, whatever you have made here. Okay, and then we'll go to schema definition again. I will add one more intent here. Switch off. Click on this. We'll add the same uh, utterances here with but now it should be for off. Select the intent. Turn light off. Switch off the fan. Put the fan off. Put the light off. Turn off the light. Switch the fan off. Like this. Okay, as usual, again, we'll have to mark the entities. Okay, light, light, fan, fan, light. We have marked all of them as entity of kind device. Okay, now uh, we have added the data. I mean, we have added all the utterances and entities and everything. Now the next step is to train the model. For that, okay, before that I'll have to save the changes. Don't forget that. Go to training jobs, start a training job, train a new model, enter the model name. Here you will have to enter the a model name, project name you had created. Sorry, not the project name. You can choose any name, any unique name here. Train CLU. I'll just put this name. Uh, Training mode, standard training free one is fine. Data splitting. Automatically split the testing set from training data. So whatever data we have entered in the previous steps, 80% of the data will be used for training and 20% of it will be used for testing. And click on train. So training is in progress now. It takes some time. Let's wait for some time till it completes the training. Okay, training is completed. Next step is to deploy this model. To use a trained model in a client application, we must deploy it as an endpoint to which the client applications can send new utterances from which intents and entities will be predicted. Uh, Go to deployment model and click on add deployment. You will have to give a name here, create a new deployment name, CLU deployment, okay, and assign trained model to your deployment name. Add a trained model to your selected deployment name. Here you'll have to choose the model, train CLU. Click on deploy. Okay, deployment completed. Now we will test this deployment. Okay, for that, go to testing deployments tab and choose the deployment, CLU deployment. This is the deployment which you had done. We'll test this deployment, okay, by entering some text here. Let's test with switch the light on. Okay, click on run test. Yeah, here it gives the result. So it has identified intent as switch on and entity as light. Okay, and it has also given the confidence score also 95.56% for this intent and 100% for the entity, that is light. Uh, so how did it do it? So we had trained this model. Okay, for example, this is what we had put. This is what we had put as training data. Switch the light on. So from this training, it has identified that switch on from this sentence s- from the from this sentence as entity, sorry, intent, and light as the entity. Okay, and a JSON tab, it shows the comparative confidence for each potential intent. The one with highest confidence score uh, is the uh, is the is the predicted intent. For example, this is the highest one, highest confidence score than this one. Okay, so that's why this will be chosen. Now let's try with different utterances. Okay, let's try with turn off the fan. To run test, go to results. Yeah. So again, it could identify the intent. Sorry. Yeah, intent of switch off with 96% and device as fan. Let's try with the entity which we haven't used while training. Okay. For example, turn off the engine we'll use. Okay, the engine we haven't given in the training data. Okay, run test. Okay, now this is interesting. It has identified intent, a switch off. Okay, as 89%, but it hasn't identified any entity because we haven't defined any entity with engine. Okay, that's why it hasn't identified any entity. So likewise, we have successfully configured a conversational language project and defined entities, intents, and utterances. And we also saw how to train and deploy a model in Language Studio. And then we tried it with both utterances, which are defined and undefined. I mean, with some that we did not explicitly define, but the model was able to determine. So, conclusion is conversational language understanding provides the intelligence and interpret the intention of the input. It doesn't perform any actions as such like turning off the light or turning on the light like that. A developer would need to build an application that uses conversational language understanding model uh, to determine the user's intent and then automate that process using this model. Thanks for watching.